I'm Ethan Mock, and I'm here doing the Module 2, Lesson 2, Activity 2 home experiment, starting off with the balloon in the bottle. So we've got two 1-liter bottles, and I have placed a balloon inside each of the bottles, stretching it over the cap, so over the neck so it stays in place. And while this bottle has stayed intact, this bottle I've taken a nail and poked a small hole in it. So now I'm going to try to inflate the bottles in both balloons. And do I think they will inflate in both bottles? I think this one will successfully inflate, but I don't think this one will. Because since this one has a hole, there is a place for the air to get out, and therefore rather than being trapped in here and condensing and building up air pressure, the air can get out and be displaced by the air I'm putting into the balloon as the balloon goes larger. Here, however, all the air is trapped in there. So as I try to force more air in and make the balloon wider, the air starts to get compressed and the pressure builds up because there's no room for the air to go. So that's my hypothesis, and let's try it. Alright, so far so good. This didn't get much progress at all here with the non-hole bottle, so let's try the bottle with the hole. Much better progress. As you can see, the balloon successfully inflated to fill this whole section of the bottle, so yeah, having the hole in it allows air to travel in or be forced out, which therefore allows me to displace air with the air I'm putting in without building too much pressure. Now let's see what's next. Now I'm going to fully inflate it while holding and then hold my finger over the hole. So. Alright, I have the air trapped in both holes, and what I think will happen when I remove my finger? I think by removing my finger, the air will rush back into the bottle, and it will displace the air in the balloon and force it out. So, actually I can remove my finger and it stays there. That's pretty cool. So let's see what happens when I remove my finger. I was correct. The air moves back into the bottle and the air pressure builds up and it forces the air that I forced in here out. So finally, to finish off this activity, we're going to try that one more time. I'm going to inflate it, and then I'm going to fill the water, this balloon with water. So. Doesn't seem to be working. Give us a second. Not bad, I held the hole too soon. Alright, so now we're going to head over here to the sink. We've got our sink, and we've got our funnel. We're going to fill the balloon with water. Let's fill it up some more. Alright, the water's pretty full now. So now the question is, when I let my finger off the hole and let the air back in, will that be strong enough to force the water out? And I think, let's see. Alright, so let's think about this mathematically. So air pressure it's the force of gravity times density times height. So the fact that water is denser than air may mean that it's more difficult for the air to push the water out, and therefore it may not. But at the same time, my hypothesis at the moment is that because the water is denser, the air will be incapable of pushing it out. So let's see what happens. Well, I was incorrect, but that's not a bad thing because that looked pretty cool. So there we have it. The air coming back in through the hole, it builds up the air pressure, and it builds it up to a strong enough force that the air can be forced out. As for why that is, oh, okay. I guess you could I'm not quite sure myself, but I guess you could say that because pressure is also force over area, since the area that the air was coming in through was a really tiny hole, I can't even find it right now, it's so tiny, that may have contributed to the pressure of the air inflowing and made it much greater to the point that it was able to eject water. As, of course, just a theory, I will probably check with you about that, but yeah, there you have it, the first experiment.